Okay, so for today, we'll be looking at this next section of our topic, and this is on the four types of quantified propositions. So if you have your modules with you, will you turn your modules to the section where you will find this portion? And under this, we have four types. We have the universal affirmative, we have the universal negative, we have the existential affirmative, and the existential negative. So in our last lesson, we have discussed our two quantifiers. We have our universal quantifier for all, and then we have our existential quantifier, the quantifier there exists. Okay. So again, just a quick review for the universal quantifier. We say that the truth value of the proposition will be true if for all the elements in the universe of this course, the proposition is being satisfied. While for the existential quantifier, we just need one element in the universe of this course to satisfy the condition to make the entire proposition true. So now let's discuss each of this. For the universal affirmative, let's have this example. So if we will now let h of x denote x is human. So we have our representation and then m of x where x is mortal. So if we want now to have our universal affirmative, then we can consider the statement all humans are mortal. Universal. So for all humans are mortal. And if we will now use our notation, this will now be denoted as for all x, h of x implies m of x. So this statement, the statement all humans are mortal can now be translated as for all x, h of x implies m of x. So that's for our universal affirmative. And then if we want now to have an example of the universal negative, still sticking with the same example, h of x denoting x is human, m of x is being mortal, then the universal negative will now be given by the statement no humans are mortals. No humans are mortal. Actually, we can rephrase this as all humans are not mortal. That would be one and the same thing. And in notation form, we can have this as, again, for all x, h of x implies this time we now negate it. We have not m of x. So we have again our translation, no humans are mortal or all humans are not mortal. The third type is our existential affirmative. So we now see our keyword here for the existential quantifier, some. Some humans are mortal. Therefore, this will now be denoted as there exists an x. We have h of x and m of x. So look at the difference. When we were using earlier the universal quantifier, we find there uh, the symbol for if then. But when we now have considered the existential quantifier, we now have our conjunction end. And the fourth type is our existential negative. Using the same example, we now have some humans are not mortal, and by notation, it will now be given by there exists an x, we have h of x and not m of x. So this is now the notation form of some humans are not mortal. So again, if you will look at the summary there, when we are looking at the universal affirmative, we have we have the use of the symbol for all, okay? And then you have your variable. So let's say you have your variable x, and then you will have your first proposition implies your second proposition. For your universal negative, you use for all, then your variable, you have your first proposition implies the second proposition, but this will now be negated. And then for the existential affirmative, you use your symbol for there exists, followed by your variable, and then your first proposition, followed now by your conjunction end with the second proposition. And the last one, for the existential negative, you use your there exists symbol, your variable, first proposition, conjunction, second proposition with the negative. So please take note of that. And what's the important part here? So when we're using uh, for all, we have implies. But when we are using there exists, we have our conjunction. So please remember that. Now let's look at some examples. First example, all members are either parents or teachers. So how do we now treat this? First, let's do our representation. So how do we represent this? We can now let, we can now, why can't we not edit this? We have, okay, for this one, we can start by saying we can now let mx, maybe m for members. So we can let mx represent if uh, x is a, sorry, member. Okay, and then we can now have the next one. We can let the x be if x is a parent. Forgive me for, oops, the underwriting there. So if x is a parent, and then we can have the last one, dx. This is if x is a parent, teacher, I mean. If x is a teacher, okay. So what do we do next here? Let's analyze our statement. So we have our keyword here. All members are either parents or teachers. So how do we now write our answer there? So we have universal quantifier for all our variable x, and then all members. So if x is a member, we use mx. Since this is now our universal quantifier, then we have our symbol implies. And let's read again the problem. All members are either parents or teachers. Parent or teacher. We have tx. So that will now be our notation. All members are either parents or teachers. Next example, we have some politicians, okay? Some politicians are either disloyal or misguided. So let's do the representation. We can let X if X is a politician, and then maybe we can have dx when X is disloyal, and we can have mx when X is misguided. Therefore, if we will now translate this in symbol, our keyword sum, therefore we use the existential quantifier. There exists an X. We have politicians, okay, are either, again, we have either disloyal or misguided. So this will now be there exists, because of the word some, an X such that our X is a politician, and we have either this X is disloyal or misguided. So there you have it. So we have some politicians are either disloyal or misguided. Some more examples. All birds can fly. So representation, we have our representation. We can let bx if x is a bird, and then we can have fx if x can fly. Analyze keyword all. Therefore, we use our universal quantifier followed by the variable. All birds can fly. So x is a bird and can fly. All birds can fly. So this will now be under universal affirmative. We were using for all, therefore we use the if then symbol here, followed by f of x if x can fly. Okay, so we have there, let bx if x is a bird. Just complete this please, and then here if x can, sorry, magsulat, x can fly. Next number. So for number 4, we can use the same notation or the same representation as number 3. We have bx if x is a bird, fx if x can fly. So number 4, this is now under universal negation for all. So we again see here the keyword all. So for all x, so this is now universal negative. Not all birds can fly, or we can also translate this as all birds cannot fly. Not all birds. Okay, not all birds. I mean, I think we have. Please forgive me for this one. Let's go over again the statement. Not all birds can fly. Therefore, uh, look at the statement again. Let's analyze this again. Not all. So if not all, it means there exist some birds that can fly, or we can translate this as not all. Therefore, we can rephrase this as some. So please forgive me for that one. Let's change our original representation. So not because we have here the word all does it mean we will use for all automatically. So let's go over again the statement. Not all, so that can be translated as some. Therefore, we now consider the existential quantifier. So for some x, so some birds can fly. So we have there exists bx such that bx can fly. Since we're using now the existential quantifier, then we use here our conjunction end. Example, all babies are illogical. All babies are illogical. Let's represent this first. So we can let bx if x will be a baby, and then we can have maybe ix if x is illogical. But please, when you will write your solution, just complete your labeling. So you have let bx if x is a baby, ix if x is illogical. So analyzing this, we have our keyword all. All babies are illogical. So we can use the universal quantifier for all x. We have bx if x is a baby. Since this is the universal quantifier, therefore we use if then, or the symbol for implies. For all babies are illogical, so we're using our symbol ix for logical. Some babies are illogical. So in the earlier example, all babies are illogical. And again, for this one, we're representing if x is a baby, then that will be bx. If x is illogical, we can use ix. And the keyword here is some. Therefore, we use the existential quantifier. There exists an x such that if x is a baby, then we have being illogical. So we have it in this manner. So some babies, we're using now the existential quantifier. There exists an x such that this x is a baby, and at the same time this x is illogical. Next example, if Joseph is a man, then Joseph is a giant. If Joseph is a man, so how do we represent that? So let's say we have if x is Joseph, can represent it as jx. Then if x is a man and if x is a giant. Okay. If Joseph is a man, then Joseph is a giant. So how else can we rephrase this? So if you will look at this one, we can rephrase it as there there is a man who is a Joseph, and this man is a giant. If this man is Joseph, then this man must be a giant. So if Joseph is a man, then Joseph is a giant. So we can use here the existential quantifier. There exists an x such that this x is a Joseph. Okay. And and how do we represent this? And this Joseph is a man. So if Joseph is a man, then Joseph is a giant. Okay, did we get that? So there exists an x such that x is Joseph. So if Joseph is this being referred to as x, then this Joseph is a man and at the same time is a giant. Okay, and going over the rule, since we are using here the existential quantifier, then we have here our conjunction. We are not looking at this connective here because this connective here is now being represented by this if-then clause. And number 8, there is a student who likes math but not history. Is this true for your case or it's the other way around? Maybe for your case, there is a student who likes history but not math. But since this is discrete math, so I think we should get into the statement that you like math, but maybe you don't like history. Okay, so there is a student. There is a student. So if that x is a student, we can represent that as x. Then if the student likes mathematics, maybe we can let that as mx. If that student's if that student, I mean, sorry, if that student will like history, then we can represent that as hx. But don't forget that we have here our negation. Going over the statement again, there is a student. There is a student. There is an x such that our x is a student. Since we are using the existential quantifier, we use here the conjunction and. And the student likes mathematics, so m of x, but not. So we use and that student does not like history. Okay, there you have it. So there is a student, there is that student. So if X is a student, that student likes math, and at the same time, that student does not like history. Okay, so there you have it for your uh, four types of quantified propositions. You have your universal affirmative, universal negative, existential affirmative, and your existential negative. So remember again our hint when we're using our universal quantifier, we use here implies. If we have our existential quantifier, we use here our conjunction. If it's an affirmative, you don't see here the negation symbol. If it's a negation, then you see the negation symbol in the second proposition. So that will be the short lesson for today. So just go over again the examples that I have given here. So till our next lecture, God bless you all.